Hello students, this is my video lecture number 2 and today's topic is uniform motion and non-uniform motion. Now, what is uniform motion? So a body has uniform motion if it travels equal distances in equal interval of time, no matter how small these interval may be. For example, suppose a body is moving at a speed of 10 meters per second. So this means that every second body covers equal distance of 10 meters. That is, in first second, distance covered by body is 10 meter. In second, distance covered by body is again 10 meter. In third second, again body covers a distance of 10 meters and so on. So such type of motion where body is covering equal distances, in this case distance covered is 10 meter every second, then such type of motion is known as uniform motion. Now this is distance time graph for uniform motion, and distance time graph for uniform motion is a straight line. Now non-uniform motion. Non-uniform motion is what? A body has non-uniform motion if it travels unequal distances in equal interval of time. For example, if you drop ball from the roof of a tall building, then suppose in first second distance covered by the falling ball is 4.8 meter. In second, as ball speeds up, distance covered by ball is 14.7 meter. In third second, it is 24.5 meter. So time interval is same, 1 second, but for every second, distance covered by falling ball is different. In first second, it is 4.8 meter. In second, it is 14 point. So these are unequal distances. Time is equal, 1 second, but every second, distance covered by body is unequal. So such type of motion is known as non-uniform motion. So we can say the motion of a freely falling body is an example of non-uniform motion. Motion of a train starting from railway station is also an example of non-uniform motion. Now why? Because when train starts, in first second, distance covered by train is small. Now as train speeds up, in second, distance traveled by train it increases and so on. So as time progresses, distance traveled by train every second it changes. So train is covering unequal distances in equal interval of time. So its motion is also non-uniform motion. Now distance time graph for non-uniform motion is a curved line. Here you can see. Now next topic is speed. Speed of a body gives us an idea of how fast or how slow a body is moving. If speed of a body is more, then it is moving fast. If speed of body is less, it is moving slow, and so on. Now in terms of definition, we can say speed of body is the distance traveled by it per unit time. So speed is equal to distance traveled upon time taken. You already know this formula. Now if body travels distance s, now distance is denoted by s in time t, then its speed is v and it is given by v is equal to s by t. So this is the general formula for speed. Here v represents speed, s represent distance covered, t represents time. So v is equal to s by t. So here we have three values. If any two values are known to you, you can easily calculate third one. Now SI unit of speed is meter per second. There is bigger unit of speed also, that is kilometer per hour. Sometime we measure speed in centimeter per second also. Now speed of a running car at any instant of time is shown by an instrument called speedometer. Speedometer is used to measure the speed of body. Distance traveled by a car is measured by another instrument called odometer. Now average speed. Average speed is simply total distance traveled by a body upon total time taken to cover this distance. Now you must have seen while traveling through a car that it is very difficult to maintain a constant speed of the car because brakes are to be applied either to reduce the speed of the car or to stop the car due to various reasons. So speed is not constant. So this formula, that is distance traveled upon time taken, it simply gives you average speed. Now let us take an example. Suppose a car travels a distance of 100 km in 4 hours. So according to formula, average speed is 100 by 4, that is 25 km per hour. Now 25 kilometer per hour average speed does not mean that car is moving with this speed all the time. Now if road is empty, road is straight and there is no traffic, then speed may be greater than 25 kilometer per hour. If road is crowded, then speed may be much less than 25 kilometer per hour. Next topic is uniform speed. So body has a uniform speed if it travels equal distances in equal interval of time, no matter how small these intervals may be. Now let us understand this term, no matter how small these interval may be. Now suppose a car is moving at a speed of 60 km per hour. So 60 km per hour means that every hour distance covered by car is 60 kilometers. Or we can also say that every half hour distance covered by the car is 30 kilometers, or every quarter of an hour, which means every 15 minutes car is traveling a distance of 15 kilometer. Or if we take every minute, so every minute car covers a distance of 1 kilometer, and every second 1 by 60 kilometer. So as you can see, no matter what time interval is, distance traveled by car or distance covered by car is same. If you take time interval to be 1 minute, so every minute car will cover a distance of 1 kilometer. If you take this, if you take half an hour, time to be half an hour, so every half an hour distance covered by car is 30 kilometers. So no matter how small the time interval is, distance traveled is always going to be same. Now here is an example. A scooterist covers a distance of 3 kilometers in 5 minutes. Calculate speed first in centimeter per second, B in meters per second, C in kilometers per hour. Now distance is given to us in kilometers and time is given to us in minutes. So if we want to calculate speed in centimeter per second, so we have to calculate kilometers into centimeters. So 3 kilometers is equal to 3 into 1000, this much meters, and again multiply by 100. So this is the distance traveled in centimeter. Time taken is 5 minutes. So 5 multiplied by 60 gives you 300. So 300 seconds. So speed is 300,000 upon 300, which is equal to 1000 centimeters per second. Now if distance is to speed is to be calculated in meters per second, so distance traveled should be in meters. So 3000 meters, 3 kilometers is equal to, convert 3 kilometer into meters, time into seconds, so 5 minutes is equal to 300 seconds, speed is equal to 3000 upon 300, so 10 meter per second. Point C, in kilometer per hour. So distance is already given to us in kilometers, so there is no need to change it. Now time taken is 5 minutes, so convert 5 minutes into hours, so 5 upon 60 hours. Now if you calculate, then speed comes out to be 36 kilometer per hour. Now this is second numerical, and you have to solve this numerical by yourself. The train A traveled a distance of 120 kilometer in 3 hours, whereas another train B traveled a distance of 180 kilometer in 4 hours. Which train traveled faster? Now third numerical. A car travels 30 kilometer at a uniform speed of 40 km per hour and next 30 km at a uniform speed of 20 km per hour. Find the average speed. Now answer of this question is given here. Fourth question. On a 120 km track, a train travels the first 30 km at a uniform speed of 30 km per hour. How fast must the train travel the next 90 kilometers so as to average 60 km per hour for the entire trip? So for entire trip, the average speed should come out to be 60 km per hour, and answer to this question is 90 km per hour. Now our next term is velocity. Now speed gives us information about the magnitude of a moving body, but it does not give any information about the direction. So our next term is velocity. Velocity gives us information about both magnitude as well as direction of the moving body. So velocity is simply distance traveled in a given direction upon time taken. Because we need information about direction, so distance traveled in a given direction, we have to take direction upon time taken. Now v is equal to s by t. This formula is same as the formula of speed. Now we know that in previous lecture I discussed about displacement. Now we know that distance traveled in a given direction is simply displacement. So velocity is displacement upon time. So we can rewrite this equation as velocity is equal to displacement. Distance traveled in a given direction is displacement. So displacement upon time. Now SI unit of velocity is meter per second. This is same as the unit of speed. Now bigger unit is kilometer per hour. Now what is the difference between speed and velocity? Speed has only magnitude but no direction. Velocity has magnitude as well as direction. So we can say speed is a scalar quantity, and scalar quantity is that quantity that has magnitude only. Velocity is a vector quantity. Vector quantities are those quantities which have magnitude as well as direction. Now here we have a statement that is 25 km per hour. Suppose a body is moving at a speed of 25 km per hour. So this represents speed. Now if it is written that 25 km per hour towards north, so here magnitude is there as well as direction is there. So this is the statement for velocity. Here we have information about both the magnitude and direction. Now what is uniform velocity? A body has uniform velocity if it travels in a specified direction, in a straight line, and moves over equal distances in equal interval of time, no matter how small these time intervals may be. So condition for uniform velocity is that body should be moving in straight line and in a particular direction. For example, if body is moving in north, so it should keep moving in north direction in a straight line. If this body changes its direction, then its velocity is not uniform. Now there are two ways in which velocity of a body can be changed. Now look at this statement, 25 km towards north. Now this is velocity. So this velocity can be changed by changing either the magnitude. You change this magnitude, change speed to 24 km per hour, 26 km per hour. You have to change this magnitude. So if you change this magnitude, velocity is changed. Now second is, you don't need to change the magnitude, you just change the direction. If you change the direction of a moving body, irrespective of the fact that its speed is still constant, its velocity will be changed. For example, suppose this body is going at a speed of 25 km per hour in north direction. Now without changing the magnitude, you change direction of this body. Suppose now after moving some distance, the direction of this body is changed to south. Now this body starts moving at 25 km per hour in south direction. So we have changed the direction. So if there is change of direction, there is change of velocity. So there are two ways to change velocity, either by changing the magnitude or by changing the direction. When you change the direction, velocity is changed irrespective of the fact that its speed, its magnitude is still constant. Body is continuously moving at a speed of 25 km per hour, but its speed changes, then its velocity also changes. Now speed and velocity are not always equal in magnitude. Most of the time speed and velocity are same, but this statement is not always true. Now to understand this concept, let us look at this diagram. Now this is home, this is shop, and separation between home and shop is 100 meter. A boy runs from home and reaches shop, and it took him 50 seconds to cover this distance of 100 meters. Now what is the speed of boy? According to formula, speed of the boy is distance upon time. Now distance is 100 meter. Time taken by the boy to go from home to shop is 50 seconds. So its speed is 2 meter per second. Now what is the velocity? Velocity is displacement upon time. Now displacement means distance traveled in a specified direction. Now this boy is running in east direction. So 100 meter in east, or 100 meter towards east. So this is the displacement of this boy upon 50 second. So velocity will be 2 meter per second. Now here you can see 2 meter per second is the magnitude of speed, 2 meter per second is the magnitude of velocity, and they are same. So magnitude of speed and velocity of a moving body is equal only if body moves in a single straight line. as long as body is moving in a single straight line, the magnitude of speed and velocity are going to be same. There will be no difference. Now, suppose this boy, he runs back to his home. After reaching shop, he runs back to his home, and it again took him 50 seconds to go from shop to home. So what is the distance traveled by this boy? Distance traveled is 100 meter plus 100 meter, that is 200 meters. And what is the time taken? 50 seconds when he goes from home to shop, and again another 50 seconds when he goes back from shop to home. So time is going to be 50 plus 50, that is 100 seconds. Now what is the displacement of this boy? Now displacement is the shortest straight line distance between initial point and final point. When this boy goes to shop and comes back home, its displacement is going to be 0. Why? Because distance between initial point and final point is 0. He has again reached his home. So in this case, distance traveled is 100 meter plus 100 meter. 100 meter when he goes from home to shop, and again 100 meter when he goes back from shop to home. So 200 meter. Time is 100 seconds. So speed is 2 meter per second. Now what is the displacement? As I have said, 0 meter. Why? Because distance between initial point and final point is 0, and time is 100 seconds, so velocity is going to be 0 meter per second. So in this case you can see the magnitude of speed and velocity, they are not same, because after reaching shop this boy changed his direction. He first moves in the east direction. After reaching shop he changed his direction and he moves to the west direction. Now because of this, according to the definition, their speed and velocity, they are not going to be same now. So as you can see, his velocity is 0 meter per second, but his speed is 2 meter per second. Why 0? Because displacement is 0, and displacement is 0 because he has come back to the point from where he started his journey. Thank you.